Hello everyone, welcome to another video. In this video we are going to go over some concepts in linear algebra, linear graphs, and also some of the concepts in coordinate geometry, but don't really to be obsessed with this term, coordinate geometry. Is just about the Cartesian plane and on a plane. Geometry basically means many shapes, so we are gonna cover some shapes on a plane, and after that we are gonna move on to quadratic algebra and then maybe factorization or something. Yeah, so let's have a look at this first concept, the x-intercept. What is the x-intercept? I'm pretty sure it's pretty straightforward for everyone because we've already covered about the y-intercept. So the definition of y-intercept was the point where a line crosses the y-axis. So let's have a look at this specific example, this linear graph. And this graph crosses the y-axis here. And then crosses the x-axis here. So this is called y-intercept. So obviously, this is called x-intercept. Usually, at this point, the value of y is always 0. The same way when it comes to y-intercept, the y coordinate is always 0. So usually it's something 0. So x-intercept usually sorry. Yeah, this should be 0 something. This is the y-intercept. When it comes to x-intercept, the coordinates look like this. Something and 0. Yeah, so that's the difference. Then how do you find the x-intercept? It's just pretty much the same as finding the y-intercept. Let's have a look at this specific example. So when we wanna find the y-intercept, we usually put 0 into x and then find the y value. So it's same, just vice versa. If we wanna find the x-intercept, then just put 0 into y and then find the x value. So let's have a look at this specific example, y equals 2x minus 6. So just again, let's find the y-intercept first because we've done that before. Put 0 into x, then y equals 2x minus 6 is equal to, this will be cancelled, and then so my negative 6. So the y-intercept would be 0 minus 6. So now if we want to find the x-intercept, then put 0 into y. So 0 equals 2x minus 6. So in this case, x equals to 3, and that's how you get x-intercept 3, 0. The next concept is not really new, but I don't know, but somehow I haven't covered when the gradient is negative, when the slope is negative. So when you see line graph, we've seen so many graphs like this. So these are basically graphs that have a positive gradient, positive slope. So the equation would look like y equals, we usually write mx plus n, and m is positive. Then also there are some other kind of graphs like this. It goes to the right bottom side. So when x increases, in this case, y decreases. let's compare these 2 points. So we usually, when it comes to slope or gradient, we calculate rise over run. So this is run. So run is pretty much the same, but like rise, it doesn't really rise technically. It falls. It goes down. So in this case, this rise is negative. It's a negative number. It could be like -3 or -4, something like that. So in this case, when x increases, y decreases. When graphs look like this, then when x increases, y also increases at the same time. So when lines have a negative gradient, that basically means line falls left to right, And there is one example here. Y equals -2x plus 4 has a gradient of -2. So like I said, when the gradient is negative, the line slopes downward as you move from left to right. So like a rise is the negative number. Then another question might be this line, these kind of lines. Why do these like fall left to right? Why do they have negative gradient? Let's have a look at these 2 examples. The left one, let's say I want to know the gradient of this graph. So gradient is rise over run, and also change in y, and divided by change in x. And then let's just think about this y-intercept. Let's say this is 0, 1, and this is -1, 0. So when we calculate rise over run, usually what we do is y2 minus y1 over x2 minus x1. So in this case, x1, y1 is equal to -1, 0, and then x2, y2 equals to 0, 1. So y2 minus y1, so this is 1 minus 0, and then x2 minus x1, so 0 minus -1. So this will be 1 over 1. So that's why this is 1. Now let's have a look at this one. Let's say now it is 0, 2, and then this is 2, 0. And then if we wanna find the gradient, then let's say x1, y1 equals 0, 2, and x2, y2 equals 2, 0. So y2 minus y1 here, y2 minus y1, x2 minus x1 would look like, let's have a look at here, y2 minus y1, 0 minus 2, over x2 minus x1, 2 minus 0. So this is -2 over 2, which is -1. So yeah, that's why if you have a careful look at this graph, then let's have a look at these x coordinates. If you see, like, it increases by 2, but these y coordinates, it decreases. It was 2 at first, but it becomes 0. That means it goes down. So that's why when we calculate this gradient, those two have different value. Like one is positive while the other one is negative. So that's why when we find the gradient, we got the negative value. Yeah. The next one is the midpoint. I'm pretty sure like it's pretty straightforward. Let's say you have 2 points on a Cartesian plane, and then let's say this is 1 1, and then this is like 4 5, and you want to find the midpoint. Then you can just find the middle. How to find the exact midpoint between 1 and 4? That basically just combine them and then divide it by 2. 1 plus 4 over 2. Then same for y coordinates. 1 plus 5 over 2. So that's how you get this formula. So x1 plus x2 over 2. y1 plus y2 over 2. So like there is one example. Yeah, it's just easy to remember and pretty straightforward. Yeah, it's probably it's not really difficult. Distance could be really complicated, but like after getting the core concept, like why it is the case, then it could be really easy. Let's have a look at this. No, not triangle. Yeah, this is like from triangle, but let me just not this one. Yeah, not this one. Sorry. There are 2 points here, and then you want to know the distance. Then use the Pythagoras theorem that we learned. So like the only way to find this distance is draw a right angle triangle. Why the right angle triangle? Because it is really easy to find this distance and this distance. Why? Because if we have maybe not 1 4, just let's use the same one, and then maybe 4 5. If you have a look at x coordinates 1 and 4, then just if you see the difference, then it's 3, then it is pretty clear that the distance between these 2 points is 3, because it's the just same x coordinates, the difference between x coordinates. Look at here, this is x-axis, and then here you have 1 0 here, and then 4 0 here. So like you are using these x coordinates to find the distance between those 2 points. Same goes for y coordinates. 1 is here and 5 is here. So here it should be 4. So now we want to know the distance. And when you really think about it, this is just hypotenuse of this right angle triangle. And then we know the other 2 sides. So like that's how we get this hypotenuse. Just use the Pythagoras theorem, like a squared plus b squared equals c squared. And then now in this case, a is x2 minus x1, b is y2 minus y1. So that's how we get this complicated formula. x2 minus x1 squared plus y2 minus y1, and then squared, and then square root equals c. And this is the distance.